So given the equation of a straight line, how can we determine the x as well as the y-intercept of a line? If that's the case, let's say we have y is equal, now it should be, let's say 3x minus 2. Let's say that's the case. So how can we be able to determine the x-intercept as well as the y-intercept of the graph of this actual equation? So by the way, we understand that the x-intercept are actually at the point in which the line is cutting across the x-axis. That's what we call x-intercept, and there y is given as 0. So hence we'll have it as 0 is equal to 3x minus 2. And that will have it as, now x is equal to 2 over 3. So that is the actually x-intercept of the graph. So which means at that point we have the coordinates given as should be 2 over 3 comma 0. These are the coordinates at the x-intercept. If at all they may be needed, but this is the x-intercept of the interest, but this is the coordinates for the x-intercept actually at the point in which the line is cutting across the x-axis. Now how about the y-intercept? So y-intercept. So on the y-intercept, x is given as 0, hence we'll have y is equal to 3 times 0 minus 2, of which y will be given as the negative 2. So that is, so at that point we'll have the coordinates being given as negative 2 should be 0, negative 2. So that is the y-intercept. At the y-intercept will have 0, negative 2. But this is the value of the y-intercept. Now how can we be able to come up with the graph of the straight line if we know the intercepts, that is x-intercept as well as the y-intercept? So how can we be able to be helped to have the sketch of that graph? So well, we'll have to come up with a Cartesian plane, as you have to theorize. So this is the Cartesian plane, and say this is the case. Now we'll have it as that. So know that this is the actually y-axis and that this is the x-axis. So we have the x-intercept, which is 2 over 3, should be around 0 point, should be 0 point about 6. So that is about the value 0.6. So which means it can be somewhere here. So let's think of having can be somewhere here, which means we'll have it as 2 over 3 at that point. Then what is the y-intercept? We'll have it as a negative 2. Let's say this is the negative 2. So that is the negative 2. So what is the equation? So now we just have to draw the straight line connecting the 2 points. So that is the equation of, that is the graph of the actually a function. That is the equation of a straight line that we had. So take note of that. We should have to actually sketch the linear graph if we have the x-intercept as well as the y-intercept. And let's say if we have this case, let's say have should be x plus 1 is equal to 1. So what is the x-intercept as well as the y-intercept? It's now x-intercept, it's when y is equal to 0. So which means we'll have, now should be this case. In this case we'll have it as x plus 0 is equal to 1. So x will be given as 1. So that is. And how about the y-intercept? So on the y-intercept we'll have x being given as 0. So which means we'll have y being given as 1. So what is the graph if we tend to sketch that one up to? So now we'll have it as this case. So this is the y, this is the x-axis. So which means this is 1, and what is the x-axis, x-intercept will have it as 1 as well. So which means the graph will have to lines like this. So the graph will have to lines like this. So that's actually a graph of interest. Now what if we have this case, and that should be, let's say we have, now should be x, now should be x is equal to, should be 2y minus 4. So try to have the x as well as y-intercept. And also if we have 2x minus 3x, that which is equal to 6. Also try that one out. What if we have y is equal to 2x and that minus 4? So try to have those out. So that is, so you can also be able to have the distances between the two intercepts. That is, try to have that one out. Since the, let's say, x-intercept will have the value of x, comma 0, y-intercept will have 0, comma y. You'll be able to have the distance between the two using the distance formula.